Okay, welcome ladies and gentlemen. I apologize that this got up a little later than I had hoped it would. It took me a little bit longer to kind of put this together. But nonetheless, we're going to go through lesson 7, well not lesson 7, lesson 3 here in chapter 1 and talk about the basic functions and their graphs. And by the end of this video, hopefully you can quickly identify the parent function by observing its graph. When we say parent function, we're just meaning the simplest form of a certain function. So let's take this graph and let's match the function with it. So in this graph on the top left we have the identity function, which is f of x equaling x. The top right here we have the squaring function, which is f of x equaling x squared. Bottom left is the cubing function, which is f of x equaling x cubed. And then the bottom right, f of x equaling, the bottom right, this is the square root function. So f of x equals the square root of x. Okay, onward. What is this right here? Okay. Top left graph here, this is the natural log function, so f of x equaling the natural log of x. We have the reciprocal function on the top right, so that is f of x equaling 1 over x. The bottom left here is the exponential function, f of x equaling e to the x. And then the absolute value function, f of x equaling the absolute value of x here on the bottom right. 4 more. Alright, top left we have the cosine function, f of x equals the cosine of x. And I'm going to skip and I'm going to go below and define this function. Come on, you stupid thing. Stay. Alright, so this is going to be f of x equaling the sine of x. And so you don't want to confuse these. How do you know which one is cosine? How do you want to know which one is sine? Well, look at what y is when x is 0. Cosine, y is going to be 1 when x is 0. Sine, y is going to be 0 when x is 0. Alright, back to the top right, we have this crazy looking thing. We call this the greatest integer function. So that's f of x equaling int, interception, Robert Griffin, Cleveland Browns. Alright, and then the bottom left we have the logistic function, which is f of x equaling 1 over 1 plus e to the negative x. Alright, so there are the 12 basic functions. It helps if you can memorize these, because when you have, or when you're given a function, you can kind of visually picture in your head what the graph is going to look like and vice versa. Alright, examples 1 and examples 2. This is what I want you to do on your own. In example 1, you're going to be dealing with finding the domain. These examples, they're just taking what we kind of went over with the parent function, looking at the graphs and applying the concepts from 1 to, looking at domain, looking for continuity and boundedness and all that good stuff. So I think it's a good review for you to do on your own. When you come into class, first thing tomorrow is we're going to put these answers up on the board. All right. I want to skip ahead now to the translations of the parent function. So we can alter the basic parent function slightly based on little changes that we make to the equation. If we want to move the graph, if we want to move the parent function horizontally, right or left, what we do is we add or subtract from the x. So, you notice how we have x minus 3 and the negative 3 is in the parentheses with x, so we are subtracting from the x here. In this one, we are adding to the x. And when we add to the x, what we're really going to do is move the parent function. We're going to slide it to the left. And when we subtract from the x, we're going to slide it to the right. It'd probably be a good idea if you got colored pencils or colored, you got pens of different colors to just kind of or you got highlighters would be even good, to kind of take time here and just sync up the function with the graph, because your guide notes aren't in color like this slide is. Vertical translations. All right, we're going to add or subtract a number to the function to move it up or down. So here, say we're going to add slash subtract to the y. Alright, so what does that mean? It's not as obvious as adding or subtracting to the x. So when we say adding or subtracting to the y, we mean we're just going to add or subtract something that's the thing kind of hanging out on the outside of the equation. Alright, so when we add to the y, alright, stuff usually happens that we expect to happen. Things we're going to go up. Alright, so we add 2 to the y, we're going to go up 2. The parent function is going to translate up 2. When we subtract from the y, we're going to move down 2. And I put this thing down here, a helpful hint to remember the difference between horizontal and vertical translations. So you want to think when you add to the x, go left. When you add to the y, go high. Alright, and so the opposite's true. So if you subtract to the x, go to the right. If you subtract to the y, go down. Alright, vertical and stretches and compressions are next. That's the number out in front. It multiplies the value to the whole function. So what you want to do here is notice that when the number out front is a fraction, alright, we are going to have a compression, and compressions widen the graph. And then when the number out front is greater than 1, you're going to have a stretch, or the graph is going to look, the parent function is going to look skinnier. Reflections, if we want to reflect a parent function across the x-axis, usually the number out front is negative. And then when we reflect across the y-axis, notice how we have parentheses and then the x inside the variable x is negative. Alright. And this next slide sort of sums everything up. Okay, in example 5 now, we're asked to graph the function y equals the quantity x minus 2 squared, then answer the following questions. Alright, so let's make a quick sketch. Alright, so the parent function here is just going to be y equals x squared. And so that graph is going to look something like this. Now, we are subtracting from the x. So we know when we add to the x, we go left. Well, we're subtracting, so we're going to go to the right. So the result is going to be a horizontal translation 2 units to the right there. Alright. On what interval is this function increasing? So let's do decreasing first, because I like reading it from left to right. So it is decreasing on the interval from negative infinity to 2, and we're closed on 2. Alright, and it is increasing Ooh, this is some bad writing here. And it's increasing on the interval from 2 to positive infinity. Alright, and we're closed on 2, open on both negative and positive infinity. Alright, in B it says, is the function odd, even, or neither? Alright, so if the function is even, it is symmetric across the y-axis. Not symmetric across the y-axis. Again, we're looking at y equals x minus 2 squared. Alright, is the function odd? So what we're asking ourselves, is it symmetric to the origin? No. And so it's going to be neither. Alright, a couple more. Does the function have any extremes? Alright, so let me sketch the graph again real quick here. Alright, so it is going to have a minimum. The minimum occurs at x equals 2. So we're going to say yes. We have a minimum value of 0 at x equaling 2. Alright, and then D, how does the graph relate to its parent function? It's a translation. 2 units right. Alright, easy enough. And so now we're going to go to the last slide, which is on piecewise functions. Okay, so piecewise functions. Like the name indicates, a piecewise function is one that is broken up into pieces. So instead of having a single equation, it is broken up into different equations. Without a calculator, let's graph the piecewise function. Alright, so I'm going to slide this up. Let's get this a little bit bigger. Alright, perfect. Okay, so what we're going to do, how to graph these piecewise functions, is it's very simple. We're going to take, so for each function, so we have 3 functions. Here, f of x equals x, f of x equals 2, f of x equals the square root of x. And for each of those functions, we're going to plug in, we're going to plug in, it's not writing, I have to pause this. Okay, I fixed the technical writing error. So, as I was saying, we're going to plug in -3 and we're going to plug in 0 for x, and then we're going to graph f of x equals x, on that interval. So f of x equals x. So I'm going to plug in -3 for x. So what is f of -3? Well, f of -3 is -3. So I'm going to plot the point, -3, 3. And the circle is going to be closed because it is less than or equal to. Alright, now I'm going to plug in 0. So I'm going to plug in, so what is f of 0? Well, f of 0 equals 0. Alright, so when you plug in 0 for x, you get 0 for y. And so I'm going to plot that point, 0, 0. And that's going to be closed as well because it's tough to see there, but that is a less than or equal to sign. Alright, now from this interval, so from -3 to 0, what the graph is going to look like, it's going to look like the parent function, f of x equals x. Alright, so it's just going to be a straight line. So we're going to connect the dots there. Alright. Okay, I erased what we had earlier, f of x, when we were graphing f of x equals x. So now I have we're going to deal with the f of x equaling 2. So same thing, we're going to plug in 0 for x, and when we do that, we're going to get out 2. Alright, and so we are going to be open though on 2 because it's less than. Alright, when I plug in 1 for f of x equaling 2, I'm going to get 2 again out for my y. So let's see if I'm going to be open on that as well because it's less than. And then f of x equals 2, that's just a horizontal line, so I'm going to kind of connect the dots here. Alright. Let me erase that and write f of x equaling the square root of x. Alright, so now we're going to plug 1 in for x and 4 in for x. So when I plug in 1 for x, so f of 1, come on, don't, so f of 1, so when I plug in 1 for x, the square root of 1 is 1. Alright, and so I'm going to graph the ordered pair 1, 1. And I'm going to be closed on that because it's less than or equal to. Right. Then I'm going to plug in 4, so f of 4. If I plug in 4 for x, the square root of 4, so I'm plugging in there, the square root of 4 is 2. This thing. Alright, so when x is 4, y is 2, and I am open on that. Now, f of x equals the square root of x. If you remember, that is a graph, the parent function looks something like that. And so that's how I'm going to kind of connect these two dots. Alright, so it's going to sort of be a little bit curved. Don't do that. What is going on? Getting all this way, and now this thing's going to crap out on me. Alright, so I'm going to connect these with a little bit of a curve because I'm almost looking at this interval, right, from 1 to 4. You see how it's slightly curved, so I want a nice slight curve here. And so that's the graph of this piecewise function. That's how you graph other piecewise functions. I hope this video went well. Hope you took something out of it, and you're ready to do some problems in class tomorrow.